Use of air power in warfare has been a very important component in campaigning since First World War. British used Kiev 1-pounder autocannon as a very effective anti-aircraft gun. Many other variants of field guns, machine guns were used for anti-aircraft warfare. These guns generally use 75mm to 76mm rounds. Although after war was evolved and new more destructive and heavier bombers were introduced, better and dedicated anti-aircraft guns also came into the picture. Well, in Second World War, anti-aircraft weapons became more sophisticated and many countries developed radar systems which were used for early warning. Germany's Wehrspurg radar was extensively used to detect enemy air incursions and direct anti-aircraft fire by Wehrmacht. In Second World War, guns with higher caliber were developed and were used in large scale. German 88mm flak gun was widely used across the Axis power to counter Allied air raids. Although real progress in air defense was made during Cold War with surface-to-air missiles. Although air defenses were needed to be eliminated even in World War, the terminology of SEAD wasn't used until Vietnam War. Since it was Vietnam War when USAF and US Navy first time had to face a network of enemy air defenses. Still, suppression of enemy air defense was carried out in both the world wars. British Air Force employed various new technologies to destroy German radar installations. Chaffs were first time used to confuse radars. Allied Air Force bombers also used new and more dispersed tactical formations to spread out anti-aircraft fire, consequently destroying anti-aircraft batteries. During Operation Varsity, US and British forces conducted airborne operations to capture area around Rhine River in western Germany. This operation also included mass bombing of different anti-air batteries spread across the region. But the real use of suppression of enemy air defense happened in Vietnam War, when during Operation Rolling Thunder, USAF was to destroy North Vietnamese integrated air defense systems. There were a network of SA-2 SAM sites which were dedicated for air denial. About 15% of aircraft lost by USAF and US Navy was because of integrated air defense system. This gave birth to anti-radiation missiles like Shrike and AGM-78. This also gave birth to the code name Wild Weasel, which was given to any aircraft equipped with anti-radiation weapon systems. One of the legendary anti-radiation missiles, AGM-88 HARM, with a range of over 150 km, was widely used by Israeli Air Force during 1973 Yom Kippur War. F-4 Phantom, equipped with HARM missiles, destroyed integrated air defense systems batteries of Egypt. In recent years, suppression of enemy air defense has become much more evolved. Use of electronic warfare systems to decapitate enemy radar sites coupled with a long-range standoff anti-radiation missile has become a very important part of SEAD warfare. Different kinds of missiles and bombs can be employed to destroy enemy air defense, including standoff munitions like JDAM and standoff long-range cruise missiles. But SEAD operations are not confined to missiles and bombs. Special forces can also be employed to sabotage critical systems of integrated air defense network. Although destroying enemy air defense has evolved a lot in last decade, with use of HARM targeting system and tactical electronic reconnaissance process and evaluation system, also known as TERPAS, suppression of enemy air defense has become much more precise and effective. But we should also understand that air defense system itself has also evolved a lot. Russian surface-to-air missiles like S-400 and S-300 have become very challenging against SEAD operations. Missiles used in these systems have greater range than most anti-radiation weapons, and radars used in these SAMs can locate and target hostile aircraft from very long distance. Many other disruptive technologies like GPS jammer can black out GPS guidance systems from many standoff precision guided munitions used in SEAD missions. Other technologies like radar-guided Gatling guns with over 4,000 rounds per minute can destroy incoming anti-radiation missiles very effectively in close range. It should be understood that in a typical US air operation, over 15 to 30% aircrafts are generally dedicated to suppression of enemy air defense. But is it enough? That's a different question. In future, surface-to-air warfare will be much more evolved. Weapons like directed energy weapons will be employed. Nations will have to greatly increase their suppression of enemy air defense dedicated sorties. Now there are two measures of effectiveness in which a correlation can be found, which are combat attrition and effort expended. Combat attrition is basically the relationship between number of aircraft destroyed with total number of air sorties. And effort expended is the relationship between total number of air sorties and total number of seed dedicated sorties. Now in this graph, we can clearly see that when seed dedicated sorties are low, attrition rates are high. And when seed dedicated sorties are over 20%, attrition rates are very low. According to my assessment, 25% is the effective rate of seed sorties to minimize the combat attrition. It might cost more resources, but it will save more lives and aircrafts. At the end, I will say that both seed and air defense capabilities are evolving very fast. To keep an upper hand, more dedicated assets need to be produced to effectively decimate air defense systems. I'm Spearhead. If you like these kind of videos, then please subscribe to my channel, like this video, share this video. Spearhead, over and out.